Hi guys, and welcome back to the channel. Before we get into today's video, for our usual housekeeping, all thoughts and opinions expressed in this video are mine and mine alone and do not reflect those of any company I am currently or previously have been associated with. Furthermore, I am super excited to announce that today's video is sponsored by Brilliant. But more on them later on the video, let's get into it. So this video has actually been in my backlog for quite a while because this project is actually one of my favorites I've done. Back in 2020, several months into the pandemic, when digital QR code-based menus had become pretty much the standard at all restaurants, I decided that I wanted to create one for my local coffee shop. Now, thankfully, my local coffee shop was able to stay open throughout the pandemic because they're just a little shop in a parking lot with a drive-thru, so they didn't have any indoor dining. And I initially got the idea when the manager of the coffee shop, who I had since befriended on social media, posted about needing a digital-based menu. But when I started to think about it a little bit more, I realized they needed something past just a static version of their menu in a web page. Like a lot of small local coffee shops, they only get one delivery of pastries in the morning. So as they go throughout the day and sell out of certain pastries, there needed to be a way for customers to see which pastries were actually still available on the menu versus what was already sold out. Overall, this meant that the project needed something to run the web server, some sort of microcontroller, and then it also needed a camera source to be able to view the pastry case. Now, at this point in time, there were plenty of examples online of bare bones basic web servers. I ultimately chose to create a Flask application in Python that used HTML requests to service GET and POST requests from the front-end HTML as customers requested the web page and clicked around on the web page. Furthermore, I ultimately chose to use the Avnet Mini-Z board, which is a AMD Zynq-based FPGA that has an ARM core to run a full Linux image. I ultimately chose this over something like a Raspberry Pi because the Mini-Z board has eMMC soldered directly onto the board that it can boot and run from. I had recently had another project where I used a Raspberry Pi, and due to vibrations and the project ultimately needing to move around, I was having issues with the SD card becoming loose and unseated from the Raspberry Pi, which created a whole other world of hurt for me at the time. And being somewhere in the coffee shop, it was a small space that was subject to many different types of vibrations, whether it was from cars driving by, all of the machinery. I think I was particularly worried about the actual coffee grinder, where it would be. It needed to be robust, and I didn't want any moving parts on it. So that's why I chose the Mini-Z board. I created a full Linux image using the Avnet BSP, at which point I could just treat like a Raspberry Pi at that point, running RPM-based package managers versus the Debian-based package managers in Raspberry Pi. For the full details of exactly how I did that, I have write-ups that I've done on Hackster in the past. I'll link those down below so you can go through those more in detail. But in addition to that, the Mini-Z board was also perfect because it had the exact number of ports I needed and no more. I wanted to make this a very simplistic thing that there wasn't a whole lot of room for reconfiguration errors or just being able to plug random things in. It had exactly one USB-A type port and then one port for power. So it had that one USB Type A port that was perfect for a USB-based webcam, which in my opinion is the simplest way to do image or video capture into a Linux environment. So at this point, I have my Mini-Z board running a web server to host the digital menu on and connecting to a USB webcam that I could position to look at the pastry case directly. Thankfully, their pastry case was clear glass, so it was pretty easy to position the camera to see everything that was in it. But this is where this project got really interesting because a whole bunch of things came up through this project that I wouldn't have foreseen until I got into the actual application of it. Going into a little bit more detail about the web server itself. So I have a very simple single page website at this point, where the digital menu is at the top and then the image is right below that. So you can read through the menu and then look at the pastry case itself to see if the pastry you want is still in the pastry case at that time. This was also very helpful because as the drive-through line kind of backed up, it helped eliminate how long customers spent up at the window trying to go through and be like, do you still have this pastry left? Do you still have this pastry left? They were able to easily look at the menu as they were sitting in line. But that brought up the interesting first hurdle I hit in this. So in order for the web server to be accessed externally, as in not have every customer's phone be on the Wi-Fi network of the coffee shop itself, I had to open up an external port on their network and place that Flask application on that external port for access using port forwarding, which brought up a few things such as cybersecurity risk. I needed to make sure everything was closed down, but I also needed to make sure that the increased traffic on the network didn't interfere with the rest of the coffee shop's operations, since their entire POS system was based off their network and everything else that goes into a business of needing online access. I ultimately decided against having the web page be a live video stream because I can only imagine it wouldn't take a whole lot of customers in line to just choke the network at that point. So because of that, I ultimately decided to, at the refresh or request of the page every time, I would have the camera go take a current image and then load that into the web page. That was great until I discovered that both Apple Safari and Google Chrome, in order to try to save bandwidth, if the image is still what it still thinks is the same, which ultimately means if the image name is the same, it'll cache the image and not update. So if a customer either visited the day before and looked at the menu and then came back at the menu the next day, it wouldn't refresh that image because the image name was still the same. Or if they had been in line for a long time and wanted to refresh to make sure their pastry was still there before they got up to the window, it ultimately wouldn't refresh. So in the backend Python that actually handled telling the camera to take an image and then upload it, I used a random number generator function to append a random number to every image name or every image file. That way it would fool both Safari and Chrome or any other browser that was using those cache features into thinking, or not thinking, but knowing that it was a new image every single time. That was ultimately a interesting find of how my daily browsers work. So the next issue that I ran into was ultimately I needed this device that was a very complex thing to build. I'm building a Linux image from scratch. I'm writing a web server from scratch, or well, based on example. I'm doing all this stuff from scratch to create this custom device that requires Linux knowledge, command line knowledge. I'm putting that in a coffee shop with baristas that they shouldn't need to know how to do all that stuff to troubleshoot it, reset it, turn it off and on. I needed to add some sort of easy switch. So I ultimately decided to create a boot up script that did two different things total. First of all, it handled actually connecting to the Wi-Fi network every time, because typically with these bare bones images that you create from a Yocto build, they're completely bare bones. Once you boot up, you have to do everything. You have to manually connect to Wi-Fi every time. So more akin to a full-blown host PC, I updated that to automatically connect to a specific Wi-Fi network. So to call the WPA configuration, or the WPA supplement configuration file, which is ultimately what Linux uses under the hood to look for a specific Wi-Fi name, and then that file also stores the password for that network. So at boot up, the Mini Z would automatically connect to the Wi-Fi network, and then there was also a Python script that was constantly running in the background that monitored the reset button on the Mini Z. So if something happened, there was a power cycle, the device wasn't able to connect to Wi-Fi or something, the barista could simply hit the reset button for a full reboot and just have it go through the whole process again to properly connect to Wi-Fi. Because one interesting bug I did find in that particular version of the Linux kernel is if the image wasn't able to properly shut down, as in it wasn't able to issue the halt command or issue the shutdown command to actually follow its proper shutdown sequence, when it would boot back up, it would never re-enumerate the Wi-Fi and actually connect to it again. And of course, that's obviously, random power outages are obviously a risk in field here. So that reset button kind of took care of it was kind of a catch-all for any particular issues that could come up like that. Oh, and then the third thing that script also did was run the web server itself at startup. Because by default, I would have to go in after boot up and manually tell it to start running the web server. So yes, the boot script had 3 different unique tasks for this build. 1 being connect to Wi-Fi, 2 being once Wi-Fi is connected, start the web server, and then 3 is that last script monitoring the reset button to perform a proper reboot should anything go wrong. Now, after I had gone through and developed this initial setup and gotten a version of it working, I started actually testing it at home to see how robust it was. Because like I mentioned, this needed to be something that you just set in a corner, plug in, and do nothing more than hit a reset button if it's not working. And getting into that test setup, even though I had everything initially working, I could run the web server, I could request the page, it would take an image, I had success with that. When I started going through and actually refreshing the page a whole bunch, testing, powering it on, powering it back off, I quickly discovered that I had some sort of issue with the USB-based webcam, that it wouldn't always connect. Now, I had just gotten a webcam off of Amazon. The first one, the brand was Microdia was the first brand I got. I didn't really think a whole lot about the specific brand because whenever you go through PetaLinux and you're actually building the kernel and going through like the Yocto ASCII GUIs to enable which kernel drivers you want, and then ultimately going through the root file system ASCII configurator and choosing which libraries you want, there's a web page where you can type in the device and it'll tell you which Linux kernels you need. So I went through, enabled all of those, thought I had everything, using the Video for Linux drivers, and it worked initially. But I noticed on each power-up, it was kind of a gamble as to whether or not the USB webcam would actually connect. And at first it kind of manifests itself where it's like, I reboot it once, everything's fine. And then as time went on, it slowly got worse and worse. 1 reboot here and there, oh, now it needed 2, now it needed 3. And it was one of those things where a barista's already busy, they can't sit there and constantly reboot it, even though it's just a matter of pressing a button. Digging into the command line, I looked at how the system was recognizing the camera. Because in my mind, obviously there was something going on with it actually being detected, or maybe the drivers binding to it. So at first I just used the ls-usb command to list all of the USB devices that the Mini-Z was seeing. And I noticed immediately that the Mini-Z, the Linux image on the Mini-Z, was able to see that there was a Microdia branded USB device attached to it, but it wasn't actually able to identify the specific chipset. So that immediately told me that I didn't have all of the proper kernel drivers either enabled or configured in my Yocto build. So to troubleshoot, I switched from using the ls-usb command to USB devices, and I noticed that it listed the Sonix chipset, which I hadn't previously seen, and I went back in and found a few Sonix drivers missing from my kernel configuration in PetaLinux. After adding those, I reflashed the Mini-Z with my new image, and unfortunately, while the problem improved, it wasn't eliminated. This led me to picking out a different webcam to try with a different chipset, thinking maybe there was just something incompatible with that particular chipset with the kernel version of Linux I was using at the time, which was the latest version at the time. Now this new webcam, which I also forgot to mention, the first webcam, it would also freeze about half the time after capturing an image. So it would take the image, put it in the folder, but then it would just be permanently frozen and I couldn't access it again to take a new photo without rebooting. The new camera I tried didn't have the freezing issue after taking a photo, but I was still plagued with the connecting, disconnecting issue. Furthermore, it got even worse. So I would look in the command line and it would just constantly connect, disconnect, connect, disconnect. So in the video for Linux drivers, I had it configured to where every time a new video source would be connected, it would print that out in the command line just as my debugging protocol. And I went through the same thing. I used LSUSB, USB devices list, like all those commands to make sure that I had all of the proper drivers enabled, that it could recognize the chipset, recognize the manufacturer. It all appeared to be there. So I went back again to that same website where you can type in a particular peripheral you have and it'll tell you all of the Linux kernel drivers it needs. It's linuxhardware.org. I'm sure regular Linux users are very familiar with that. But this time with the second USB webcam, I typed in the name and I noticed that I was missing the USB serial driver that I didn't have previously. So I went through again, added the USB serial and USB serial option kernel drivers, reflashed, and tried again. However, while this helped somewhat, I was still plagued with the issues of it would connect, disconnect, and it was about a 50-50 chance of whether or not after it went through its little cycle of constantly connecting and disconnecting from the USB, whether it would actually stay, it being the webcam would actually stay connected to the Linux system, or if it would just give up and not be connected. This led me to think that there was some sort of power issue, that maybe the addition of this webcam drawing the extra 5 volts over the USB was overwhelming the power supply that I had to the Mini Z overall. Initially, I just had a 5 volt 1 amp brick powering the Mini Z, so I tried again with a 5 volt 2.5 amp brick powering the whole thing. That didn't seem to have any impact. So again, I went back to my kernel configuration in PetaLinux and looked through, and I noticed in the USB drivers, the actual VBus for the USB has a current limit set in the kernel driver, or in the driver itself. The default is 2 milliamps. So I was thinking, oh yay, that's definitely it. The webcam comes on, it tries to draw more power, because I think when I looked it up, by default USB webcams draw about 120 milliamps, or at least the ones I was using did. So I'm like, oh, this makes perfect sense. It tries to draw too much current and then just constantly power cycles. So I upped that to the maximum is 900 milliamps, which didn't think my USB would use that, but just went ahead, gave it full reign. And oddly enough, that had no impact. So I was left really stumped thinking, this is acting like a power issue. I've given it as much power, more power than it needs, and it's still behaving weird. So this ultimately brought me back to look at what other kernel drivers affect the power supply to a USB peripheral like a webcam. And this is where I discovered the actual inner workings of USB OTG, or on the go. So for those that are not familiar, the OTG, or on-the-go protocol for USB, is where you have a USB host that can also be a slave device. And in the USB protocol, the host device is the one supplying power and the slave device is the one receiving. So if you have something that can act as both a host and a slave device, it will use the OTG protocol to probe the voltage bus and see if there's already a voltage present. Because if there is a voltage present, that tells the device it's a slave and doesn't need to also power the same bus and back power something potentially. So because of this USB on the go driver, there was something weird with the OTG driver within the webcam, the 2 webcams I had tried using previously, because when it would plug into the system would see the USB webcam trying to power the device, and then therefore shut off power to the webcam thinking it was the host device. And then of course, because it's not actually a host device, as soon as power was removed, the voltage bus on the USB was no longer powered, and it would fool the Mini-Z into thinking that, oh, I need to power this bus again because I actually am the host device. And that's why I was just going in this infinite loop. Back to Amazon I went to find another USB webcam because I had exhausted all configurations possible for my 2 previous. And I decided to go with my tried and true Logitech brand, because that's a brand obviously this isn't sponsored by Logitech, it's sponsored by Brilliant, but Logitech was just one of the brands of USB web I noticed I'd never had issues with. And sure enough, I think whatever Logitech drivers are built into their webcams get along great with the OTG, they get along out of the box with the Video for Linux, and as soon as I switched, I had 0 problems, it was completely stable, it behaved as normal. It no longer froze after taking an image, I didn't have the weird boot cycles where it would constantly connect, disconnect, and it connected at power up every single time. So, I've detailed that full troubleshooting process in a little bit more detail on my Hackster write-up, so I'll also have that linked below if you want to see a little bit more of like the detailed screenshots of how I determined this, because that's one thing I've realized is really hard to film, is that type of troubleshooting where I'm just hopelessly stuck on something and I don't know how to talk to a camera. If you have any tips for that, let me know. But anyway, now I had my fully robust working system that had my digital menu. I could access it through a QR code. It was taking photos as I wanted. It was finally time to go install it in my local coffee shop. Now, to actually install this in my local coffee shop, I realized I needed some sort of enclosure to put the whole thing in, and that enclosure also kind of needed to double as a mounting point for the webcam itself. Because in a coffee shop, there's lots of fine coffee dust going everywhere, and it's probably not a friendly environment to a bare PCB like the Mini-Z. Now, at the time, I did not own a 3D printer yet, and I also didn't have the patience left to draft up a custom enclosure design in some sort of CAD program. So I went exploring for off-the-shelf enclosure ideas. Given the shape and size of the Mini-Z at the time, I found just like a small plastic lunchbox for a sandwich was the best because it could seal well, and then I could simply just drill out some holes on the bottom for the USB and power cables to connect through, and then I could cover the front of it in Velcro and put Velcro on the bottom of the USB webcam to allow for it to be repositioned on the enclosure. Within the sandwich box, I found that standoffs to mount the Mini-Z worked great, and then I just drilled a little hole, like a little nail hole, so I could just put a nail on the wall and hang it like a picture. That ended up working out perfectly. Furthermore, because I had like an open surface, I was able to print off some instructions to go on the inside of the lid for a reference point for the baristas if they had to take the lid off to press the reset button. So I ended up getting to put my, at the time, newly acquired Dymo label to work to fit the retro aesthetic of the coffee shop. Now, I feel like it's worth mentioning that at the drive-thru of this coffee shop, there's no initial speaker that you pull up to and order before you get up. There's just the window of the little coffee hut itself, which is why it was important for customers to be able to see what was left in the pastry case before they got up to it, because that was just the single point in the line. And obviously at the height of the pandemic, going to a drive-through coffee shop was one of the few things we could safely do to get out of the house. So the lines were incredibly long at this coffee shop every morning. So that definitely was able to alleviate a lot of the time spent actually at the window for each customer. Now, once I got there, I did have to partner with their IT team. We actually ended up creating a whole separate Wi-Fi network for the Mini-Zed to connect to, just to further isolate it from their POS system transactions. I was able to get there, open up a port on it. I put the Mini-Zed on that port, or the web server on the Mini-Zed on that port. I also forgot to mention I did disable SSH on the Mini-Zed, because that would be a huge risk of, oh, you could just SSH into it. And then I also found that because all of this had become so standard, generating a QR code and attaching a URL to it, there's tons of websites now available to do that. At the time, they were all free, except for they would eventually time out, so you'd have to refresh the QR code every so often, but you could pay like a subscription and then your QR code would stay active permanently. Ultimately, the QR code would stay active for about a month, so it wasn't super hard to just, I couldn't justify the expense to the coffee shop to pay the subscription, so the only extra thing they had to do was print out a new sheet to go on the menu outside with the new QR code once a month. But overall, that was my process of this project for creating a digital QR code based menu for my local coffee shop. Like I said, this was a lot of fun. It was a ton of fun going in and being able to install it and then going through the drive-thru that first time and actually implementing it. That I would also like to shout them out. They are filling station in Kansas City, Missouri. So if you are ever in Kansas City, Missouri, Taylor Swift fans, be sure to check them out. They're in the parking lot there at Westport Road and Southwest Traffic Way. Love them to death there. They're still going strong. So I'm really glad to be able to help them out and very honored. And also, thank you again, Brilliant, for sponsoring this video. And let's learn a little bit more about them. So I've always enjoyed math and science all throughout school. That's why I became an engineer. And by the time I graduated with my master's degree in electrical engineering, I was convinced there was no possible way I could ever forget my basics in calculus and trigonometry, because I lived and breathed by integration, derivation, and trig identities in order to survive and thrive in my classes like physics, circuits, DSP, communications, RF, everything. So I didn't think twice about selling some of my old textbooks when I was packing up to move cities early on in my career, because for 6 years straight, there wasn't a day that polar coordinates were at the forethought of my mind. However, fast forward about 7 years into my career, I was woefully humbled after not working problem sets daily and actually doing real-world applications when I came back to do things like waveform design for an SDR project, implementing a simple integration calculation within an FPGA to integrate a streaming data source to see how much volume a sensor had measured. And oof. But that's where today's sponsor, Brilliant, comes in. Brilliant is a great online platform offering courses in math, science, and engineering in easily digestible chunks, so you can either learn new topics or brush back up on old ones as quickly as possible. Their courses are brilliantly, pun intended, designed such that it develops your problem-solving skills through interactive examples and problem sets versus you trying to read and cram and memorize as much as possible from a textbook. And because this method of learning is so much more effective, I've personally found that I understand some of these core concepts better after going through their modules versus when I initially went through it in undergrad. Furthermore, each section within a learning module is broken down into easily digestible chunks that can be completed in 10 minutes or less. So you don't have to wait until you have endless hours on end to dedicate to reading and studying from a textbook. You can simply complete a section or two each day as you find the time. Personally, I've been trading social media doom scrolling time for modules within Brilliant's courses. Brilliant offers a full range of topics for math, science, programming, data analysis, logical reasoning, AI, and even quantum computing. Like I mentioned, I've personally been using their updated calculus course to brush up and unlock some of my forgotten basics that I thought I would never forget. And I've also been using some of their other modules that I wasn't able to learn in my undergrad, such as exactly how AI works. Because, spoiler alert, I'm dating myself a little bit. There weren't AI electives when I was an undergrad. So if you're interested in learning new skills or brushing up on old ones like myself, use my code WhitneyKnitter at sign up to get 20% off a lifetime premium subscription with Brilliant, and it also helps support this channel. Let's get back to the project. Thanks for watching, everybody. This video has been a long time in the making. I hope you enjoy it. Let me know your thoughts, whether you have further questions, if you want further details. All of the subsequent tutorials that I wrote up at the time for this project will be linked in the description below, along with my code to sign up for Brilliant. It would mean a lot if you'd like to support the channel. Otherwise, subscribe, and I will see you for the next video. Okay, bye. Awkward bye. Awkward bye. Ooh, awkward bye.